So today we're going to talk about the derivative and the differentiability. Okay, we say that a function f is said to be differentiable at x equals c if the derivative of f exists at x equals c. In order for the derivative to exist at x equals c, the graph of f must have a local linearity there. What does it mean? Okay, in other words, if you zoom over in an overall at x equals c on the graph of f, the graph will look like a line, but not a vertical line. We have this situation. A function f is not differentiable x equals c if the following happens. The first example here, you have f of x is equal to the absolute value of x minus 2, meaning you have this graph, okay? And hopefully you remember this from algebra 2. F is not differentiable at x equals 2. Let's see what's going on. Because there's a sharp turn at x equals 2, so you see this corner, that means that it's not differentiable, okay? So f is differentiable for all other values of x, but not at 2. Okay, so this corner, what we call the sharp turn, it makes your function non-differentiable there. Okay, now for number 2, we have that f has a discontinuity at x equals c. In this example, we have that f of x is equal 1 over x minus 2, meaning we have an asymptote here at 2. Okay, we say that f is not differentiable at x equals 2 because there's a discontinuity at x equals 2. F is differentiable elsewhere, but not at 2. Okay, so the third case that we have over here is when f has a vertical tangent at x equals c. What in the world is a vertical tangent? It means that the slope of this line, what's going to be the slope of this line, undefined. Okay, so let's say f of x is equal to x minus 1 to the power of 1/3. You are going to have here at x equals 1, you are going to have an issue because you have a vertical tangent line. And that vertical tangent line, it's going to make at that point your function not differentiable. Okay? As mentioned before, f is going to be differentiable for all other values. Now, another one that it's pretty common to see is when f has a cusp at x equals c. Okay, so let's analyze this graph. F of x is equal to x minus 1 to the power of 2 over 3. So what's happening here is you have like a cusp, okay, at 1, x equals 1. Because there's this cusp, it's not going to be differentiable. Okay, again, it's going to be differentiable all the way, but not at x equals 1. Okay, so hopefully this helps you to graphically understand the differentiability. Okay, so here we need to list all the values for x values specifically for which the function appears to be not continuous, not differentiable. Please note something. The continuity is weaker than the differentiability. Okay, let's look at the graphs here. This graph over here is continuous, but it's not differentiable at here. This one is not continuous at 2, and it's not differentiable. This one is continuous, but not differentiable, and this one is continuous, but not differentiable. So as you can see, the differentiability power is more powerful than the continuity. Okay, so differentiability means that the function is going to be continuous, but continuity does not mean that your function is differentiable. Okay, so that's why we have this beautiful example. Okay, so let's start with non-continuous. Okay, so my function is very beautiful. Okay, and we're going to analyze this on the interval basically 0, 10. Okay. Okay, so we're going to analyze everything in this interval. Okay, so let's look at this. Okay, so it's beautifully continuous everywhere except here. Okay, so at x equals c, it's a problem. Okay, it's not continuous. That's the only continuity issue. Besides that, I'm seeing it very beautiful. Okay, so now let's analyze differentiability. We know that since it wasn't continuous, it's not going to be differentiable, but there's maybe more. Okay, so I'm going to put more x's. Okay, so here there's a corner. Okay, so it's clear that it's not differentiable at 3. Okay, so there's a sharp turn. In addition, here at 4, you know that there's a vertical tangent line, okay, which is also an issue, so that's also an issue. Okay, where else you see an issue? I don't see any issue elsewhere here, and then we have an issue here at 8. Okay, so it's not differentiable when the slopes from the left and right have different signs. Okay, so you can conclude that if you realize the slope on this side, it goes this way and this one here, so that's the problem. Okay, and that's another thing that you can realize that it's happening. Okay, so not differentiable in more places, not continuous only at one place. Okay, so you can see the difference here. So we have this graph, and they ask you at which label point is the slope of the graph 0, positive or negative. Okay, so technically what we have is that this is A, this is B, this is C, this is D, E, and F, wherever you can pick there. F. Okay, so what's going on at A? At A, the tangent line is what? Negative. Okay, you see it? This is my tangent line, so it's negative, so you know that at A, the tangent line is negative. What's going on at B? At B, what is happening, it's 0. Okay? Then at C, what happens? Positive. Okay? D, positive. Why? The slope. Look at the slope. Okay? D. What's up with E? 0. Okay? And last but not least, what's up with F? Can you conclude? We could, but it's the end. Assuming that it's coming like that, then it's going to be negative, but we are assuming stuff and things. Okay? So you can assume that. Okay, so let's move on to the next example. Okay, let f be a function which satisfies the following condition. F of 2 plus h minus f of 2 is equal to 5h minus 3h squared plus 9h cubed for all real numbers h. Find f prime of 2. We need to remember the definition of the derivative, and they are giving you the super hint. Okay, so what do you have? What I'm seeing, since they want me to find this guy, I'm going to write it out. F prime of 2 is going to be equal to the limit when h approaches to 0 of what? Technically, what I'm going to do here is, well, you know that this one becomes a 2 and this one becomes a 2, so I'm seeing that guy here. Okay, so what are you going to do? You're going to copy the situation, which is going to be h5 minus 3h squared plus 9h cubed, and then you already know that this is the same divided by what? By h. Clearly you see all the h's there, so this is going to be the limit when h approaches to 0 of what? 5 minus 3h plus 9h squared. Okay, once you compute the limit, this is going to be equal to 5, therefore f prime of 2 is equal to 5, and that's it. Okay, so let f be a function which satisfies the property of f of x plus y equals f of x minus 4 f of y plus 9 xy for all real numbers x and y, and suppose that the limit when h approaches to 0 of f of h divided by h is equal to 2. We need to use the definition of the derivative to find f prime of 2. What are you going to do? Well, follow the hint. Okay, f prime of x is going to be equal to the limit when h approaches to 0 of what? F of x plus h minus f of x divided by what? H. Okay, so from here you know that, okay, x plus h, x plus y, so this one we can replace it with h, so this one can replace it with h, and this one with h. Therefore, what do you have? You have that this is going to be the limit when x approaches to 0, and we can compute this one. Okay, how? Because you know that it's going to be f of x minus 4 f of h plus 9xh, and then you have the minus f of x. Okay, so you can just put minus f of x here. Okay, divided by h, and what happens? Boom, it cancels. Okay, so you are like, score. Okay, so what do you have here? You have that this is equal to the limit when x approaches to 0 of what? You have that it's going to be negative 4 f of h divided by h, and if you separate this, tricky enough, you realize that this would be 9x, okay? Because I cancel the h's, okay? So you have that this is going to be equal to what? Take your information, so what do you have here? You know that it's going to be what? You are like, okay, I'm seeing this guy and this one. This is the same, so I can take out my -4, so you can see it like this if you want to. If you need this step, that's fine. If you don't need it, that's fine too. Okay, so you have something like this, okay, and actually you would have something like this more specifically, to be more exact. You would have something like this, right? Okay, so now what happens? You know that this is going to be 2, okay, so you have that -4 times 2, okay, plus 9x, because this doesn't have anything to do with the x, okay, so you know that this is going to be equal to 9x minus 8, and that's it. Okay, so this is your f prime of x.